Hello. 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 Yeah. Ukimaliza hebu pitia huku kidogo. Eh, mm. Go ahead. Morning. Good morning, students.
Good morning.
Can you be able to hear me?
Yes.
Okay. Now we are going to discuss. I'm sorry, I cannot be able to see some of you. Hello.
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 You can hear me?
Yes. Yes.
Cannot be able to see some of you. Hello.
Hello.
I can be able to see some of you. Hello. Elijah, can you be able to hear me?
Yes. Yes.
Faisal, can you be able to hear me?
Yes.
Okay. Then I think we can proceed. Modime, can you hear me? Modime? Modime?
Yes, I can hear you.
Okay. I think then we can proceed. So what I'm doing today, we are going to discuss the physics papers. And what we are going to do, I'm preferring that we go through the past ICSE paper. Hello, are we together?
Yes. Yes. Yes.
Okay. We shall go through the KCSE papers, and I want us to start with KCSE 2019 paper 1. So today we shall go through KCSE 2019 paper 1. So let me share so that you can all be able to see. Once you see the paper, you can inform me. I hope you can all be able to see the paper. Hello?
Yes. Yes, we can see the paper.
Okay, you can see the paper. Then we can go through the paper. So we are going to start with the question number 1. So question number 1, we are going to have someone to read for us. Zuhair. 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 Some of us, I cannot be able to hear some of you. Okay, let me just go through the paper. I'm working on those technicalities that bring the challenges. Okay. Question 1, a micrometer screw gauge has -0.03 millimeter error. State the reading that is observed on the instrument when used to measure the diameter of a wire, whose actual diameter is 0.38. So how do we work it out? Just on it. Just give me a few minutes. I'm trying to settle a problem that I'm experiencing at the moment.
Yeah. I think.
Hello. Hello.
Hello.
Hey guys.
Okay.
Yes.
Hello.
The technicalities. I think we can start. So we are going to start with the question 1. For those who are getting in right now, for those who are joining us, we are going through ACC papers, and today we are starting with 2019 paper 1. So we have our first question. And in our first question, a micrometer screw gauge has -0.03 millimeter error. State the reading that is observed in the instrument when used to measure the diameter of a wire whose actual diameter is 0.38 millimeters. First of all, how do we handle the error that is negative? So how we deal with it, we shall start. A negative error, how do we deal with it? Ogola? Ogola, Joshua?
The negative error, you'll add the measurement you get.
That is true. So in this case, we are going to have the actual reading. Suppose the actual reading we consider it to be x. This case, we have x is it. Because we are adding, we are going to add the error, and the error we are having is 2.03. So whatever we should have, the reading of micrometers. So with that, what is going to be the value of x? Value of x. Emmanuel Kibet, give us the answer. So what answer are you going to get?
0.0. 0.3.
0.3? Yeah, that is it. 0.35 millimeters. Thank you. So if one watching is a mark and unit millimeters, the answer is 0.35
Hey, not
the one should be
surely, no way, no way.
have that upon marking so saying this. So we want to get the answer to that. Why do you think this throw was not able to start there?
Open mic and give feedback.
A lot of noise. The audio, there is a lot of background. Okay, we move on. So in this case, that's why it is not possible for the straw to suck the milk. Now, the main reason for this one, note that the straw is going to apply the pressure. And now because there is a hole at this region, you find that the pressure, the atmospheric pressure, the moment you start sucking the straw, the atmospheric pressure will get through, and you find that the internal pressure and the external pressure will be downward. Balance. So in the process, you find that when the pressure is going to balance, then there is no net pressure that is going to be left pushing the milk up the straw. So that is going to be the answer. I'm hoping we are writing somewhere.
Yeah, the first mark is awarded.
Pardon? The first mark?
Where will it be awarded?
Oh, the first mark is to show that the hole is going to allow the pressure inside collide with inner, or the hole is going to ensure that internal pressure is equal to external pressure. That is going to be the first mark. The second mark is to show that there is no pressure left up the left.
So you're all part of some daffy religion.
You're having a lot of background noise. Lot of background noise, please.
Oh,
You're having a lot of noise.
this is the world's only sensory. It's permitted. I like the sound of that.
Now move to question number 3.
No, I please.
So the
Get haughty with me. I followed you as a friend. You tricked me.
Can meet people.
Question 3. Question 3. I'm making a lot of noise. I'm trying to just reduce the background. Okay, can you move on? Hello, can you move on?
Yes.
Okay.
yes.
Then we are together. Question number 3. Set 2 ways of reducing surface tension of a liquid. 2 ways of reducing surface tension of a liquid. So, Amos, Mari, you can give us one way. Amos? Amos? Yes? Amos?
By increasing the temperature.
By increasing the temperature, that is one. So we go to Brandon Muriuki. Brandon Muriuki.
By adding impurities.
By adding impurities. So those are the two ways, increasing the temperature or adding impurities. There are some words which were being marked related to whatever we are discussing. To state by heating the liquid, it was being awarded the mark because heating, of course, is going to increase the temperature. But when it comes to impurity, don't just state by having impurities. You must talk about adding of impurities. Same case to the temperature, don't talk about by changing the temperature. It is by increasing the temperature. We go to question number 4. Figure 2 shows a round bottom flask containing a colorless liquid. The flask is fitted with a capillary tube. It is observed that on holding the flask with the bare hands, the level of the liquid in the capillary tube initially drops slightly and then rises. Explain this observation. How do you use the background? How do you use? Just 1 minute. There is something I'm trying to understand. So we move on. So we have to explain why the level of the liquid initially drops slightly and then rises. So this one, Brandon Muriuki. Brandon, or someone is raising his hand. Hold on. Hello, I can't hear you. Hello. So Brandon Muriuki. Brandon Muriuki, give us the answer.
This is because the flask will first expand, then so that the water lowers, then it will expand, thus it will rise.
That is it, but unfortunately, there are some words which you have omitted. You have the idea, but because of omitting those words, you find that you may not be awarded all the 3 marks. First of all, you need to understand that the moment you hold with bare hands, you are warming this flask. So the flask expands fast. So the first mark, you talk about the flask expands fast. That is where the first mark is going to be awarded. Then from there, the level of the liquid is going to lower because of increase in volume. Because of increase in volume. The level lowers because of increase in volume. That is the second mark. Then the third mark, you have to state that the liquid expands more than the flask. The word more, remember you are comparing the expansion of the flask and also the liquid. So you have to show that the liquid then expands more than the flask. So, and you get the 3 marks. We now move to the next question. Question number 4. The figure below shows 2 metal rods A and B of equal lengths, made of the same material but different diameters. Wax is attached to one end of each rod. A source of heat is placed between the 2 metal rods. We can be able to see a thinner metal rod, but equal length, same material, a thicker metal rod B. State with a reason what is observed on the wax. Note that the question is awarding 2 marks. So what is going to be observed on the flask? That is, not on the wax. That is what the question is asking us. Therefore, let's have Michael Waidaka. You can answer us. Michael Waidaka. Hello. I can't hear the students. I can't hear the students. Michael Waidaka. Alan Mokua. Alan Mokua, you can answer us.
Yes. So in this case, we're going to observe that the wax in B is going to melt at a faster rate compared to the wax in A. This because B has a larger cross-sectional area compared to A, hence faster conduction of heat.
That is it. We now get 2 marks. The first mark is to show that B, the wax in B melts faster. So the word faster has to be there or at a greater rate. Then the reason being, B with a bigger cross-sectional area conducts heat faster. So there is faster rate of heat conductivity. Again, I have to remind you that comparative language had to be applied in this case. Now we move to the next question. On the axis provided, sketch the displacement time graph for a trolley moving down a frictionless inclined plane till it reaches the end of the incline. Admit. Okay. Hello. Now, remember in this case, we are told that it is actually moving down a frictionless inclined plane till it reaches the end of the incline. Now, by the fact that it is moving down a frictionless surface, then which force is acting on that trolley? The force acting on the trolley.
Gravity.
The gravitational force. Therefore, in this case, because it is frictionless, we automatically expect the gravitational acceleration to work on it. So this body is going to accelerate. Therefore, the displacement time graph for a body that is going to accelerate, it is going to curve like that. So that is the nature of the graph. So let me just clean this part. Remember that to start with, it covers a shorter distance within a longer time, but as it is moving on, it covers a smaller distance interval, longer distance interval within a shorter time. Therefore, that is the graph of a body that is accelerating. We move on to the next question. Question 7. A student carrying a heavy box using the right hand is observed to lean towards the left hand side. Explain this observation. Explain this observation. Why do you think this student is going to lean towards the left? Zuhail?
Yes.
Why do you think the student is going to lean towards the left?
Sure, this is because to the center of gravity remains at the position it was. So for him to obtain stability, he should lean to the other side.
So in that you have a first mark for showing that you want to maintain the stability. Now in this case, the student carrying a heavy box using the right hand leans towards the left. Remember, when you carry your load or heavy box using your right hand, the position of the center of gravity shifts towards that side of the load. So in this case, it means that position of the COG will shift to the right. So that is where the first mark was. The position of the center of gravity shifts towards the right. Then the second mark is what Zuhail has stated, that is going to lean towards left to maintain the stability. So to maintain the stability, that is going to be the second mark. We now go to question number 8. The figure 4 shows 1 meter long uniform rod of negligible weight supporting 2 weights. So can be able to see the 2 weights, one of 10 newtons, the others of 15 newtons. Determine the position of the fulcrum from from 0 centimeters for the rod to remain in equilibrium. The question is awarding 3 marks. So where do we get our first mark? I want you to do the calculation. Do the calculation and then we get someone to give us the right answer. Do the calculation. Are you through? If you have gotten the answer, you can give us the answer. So Emmanuel Sicolia. Emmanuel Sicolia.
I'm not through.
Emmanuel Sicolia. Emmanuel, can you hear me?
Yes.
Emmanuel?
Yes, I can hear you.
So what answer are you getting?
I've not yet gotten the answer.
Oh, you are still working on it?
Yes.
Okay, Eric Motua.
Just a minute. I'm still working on it. I'm finishing it up.
Okay. So Scott Mwindi. Scott Mwindi.
Almost done. Almost done.
Almost done. Okay. Samuel Gakinya.
Almost.
Almost. Kemani.
Almost.
Okay. Daniel Jenga. What answer are you getting?
Mwalimu, I have the answer.
Pardon?
I have the answer, Mwalimu.
What is the answer?
50. The position of the center of gravity is at the 50 centimeter mark.
That is it. So the answer is 50 centimeter marks. How many are you getting 50 centimeters mark, those who are through?
Yes.
Yes.
In this case, the first mark. Okay.
Yes.
So I can see majority of you are getting 50.
But
what you are supposed to do, we can just place a pivot at any given point. And then from there, we are going to give some measurements from the pivot to where the two loads are. So we can see that from 5 centimeter mark up to 80 centimeter mark, the difference is 75. So the whole of this length is 75 centimeters. Suppose we just state that this is going to be X centimeters. Then it implies that this distance becomes 75 minus X. So this 75 minus X. At times, it is advisable to sketch on the diagram or write any necessary thing that you feel that it is going to make your work to be easier. So the first mark, of course, is stating in full that clockwise moments is equals to anti-clockwise moment. So writing that one in full, you are able to get your first mark, and we treat it like a formula mark. Then the second mark is to show
Excuse me,
clockwise
teacher.
moment.
Teacher, can you write F1? Can you write F1 times D1 is equals to F2 times D2?
It is allowed. It is allowed, yeah. It is allowed. F1 D1 is equals F2 D2. That one is allowed. Or W1 D1 is equals to W2 D2. We still allow those ones. Thank you for that question. Now we can move on. Clockwise moment, you can see that we have 15 newtons. We multiply by X. Therefore, we shall have 15. You multiply by X is equals to anti-clockwise. And anti-clockwise moment, you can see it is product of 10 and 75 minus X. Therefore, here we shall have our 10. We multiply by 75 minus X. So with this one in mind now, can we divide every part by 10? Because it is a product on this side. We divide by 10 instead of opening the brackets and having very big values. So in this case, we shall have 15 divided by 10, which is going to give us 1.5 of X being equal to, remember this 10 is going to cancel with this 10, and you are left with 75 minus X. So take this minus X to the other side, and it is going to add, and you're going to have 2.5 of X is equals to 75. So divide every side by 2.5. So 2.5 divided by, 75 divided by 2.5, we are going to get what? Is it 30?
Yes. Yes.
So it is the 30. So if
Yes.
it is 30 meters, then
Yes.
remember the question is asking us to get the position of the fulcrum from 0 centimeter. So this is 75 minus 30, we get 45. Therefore, we have 5 add 45, and the final answer, it is going to give us 50 centimeter. Remember, the question was very categorical from the 0 centimeter mark. So the answer becomes 50 centimeters. So I can see someone is speaking for me. We can now move to the second, to question number 9. State the meaning of the term radian as a unit of a measurement. So the meaning of a term radiant. So Malcolm, what is the meaning of the term radian? Malcolm, can you hear me? Malcolm, Roderick, Kimeu, Roderick, can you hear me? Salat, can you hear me? Unfortunately, I cannot be able to hear some of the students. So Michael Angwenyi, can you hear me?
Can I answer?
Yeah,
Yes.
you can answer. What is a radian? Someone to answer it.
A radian is the angle subtended at the center of a circle by arc straight to the circle. Or that's my opinion.
You have an idea, but it is incomplete. Let me assist you. It is
Chair,
an angle.
Chair,
Pardon?
the answer. Chair, can I try?
Okay. Who is answering?
Me. Me.
Your name, please.
Mbatia.
Zuhair.
Mbatia.
Okay, you can answer for.
A radian is defined as an angle subtended at the center of a circle by an arc length equal to the radius of the circle.
That is it. It is an angle subtended on a circle, at the center of a circle, by an arc length, which is equal to the radius of the circle, which is equal to the radius of the circle. So that is the answer to that. We now move to the next question. Number 10. For a fluid flowing at a velocity v in the tube of cross-sectional area A, VA is equals to constant. State two assumptions made in deriving this equation. Two assumptions made.
Chair, the answer.
One
that the fluid flow is
the fluid flow is
streamlined.
Yes.
Fluid flow is streamlined. That is one.
It's streamlined.
The fluid flow is streamlined. Another assumption. Someone else.
The fluid is non-viscous.
Non-viscous.
Fluid is non-viscous, correct. Fluid is non-viscous, correct. Another one.
The fluid is non-compressible.
Yeah, the fluid is incompressible. The fluid is incompressible. We now move to the next question, number 11. A stone of volume 800 cubic centimeters experiences an upthrust of 6.5 newtons when fully immersed in certain liquid. Determine the density of the liquid. Determine the density of the liquid. I want to give you time, 1 minute, do the calculation and you give me the answer. Do the working.
Sure. Check out the answer. The answer is 812.5 kilograms per meters cube.
That is it. 812.5 kg per cubic meter.
Yes.
So do you have more students who are getting the same answer?
Yes. Yes, yes.
Okay. Yeah. Those who could be having the challenge, let's go through it.
Yes.
So, is this one going to apply Archimedes' principle of the law of rotation?
Sure.
Archimedes.
Sure, could you?
Pardon?
Kindly.
Yes, ask your question.
Could you kindly explain how number 11 is done? Illustrations. Could you illustrate how number 11 is done?
Yeah, it is the one that I want us to go through. So I was asking, are we using Archimedes' principle or the law of flotation?
Archimedes.
Archimedes. Why are we using Archimedes? Which term or which verb do you think is making this question use Archimedes' principle?
Fully immersed.
Fully immersed.
Fully.
If you say the word immersed, so in this case, because we are using Archimedes, then we know that Archimedes' principle, the formula is upthrust is equals to rho Vg. Upthrust we have 6.5, so we write down 6.5 is equals to density of the fluid we don't know, and it is the one that we need, multiplied by the volume of the stone. Because it is fully immersed, then it means that the whole of this volume is the one that is going to be displaced. So, but remember that that density being in cubic centimeter, you have to convert into cubic meter. So it is 800 then times 10 to power negative 6 times 10 to power minus 6. That is the volume multiplied by G, and our G is 10. So we multiply by 10. So 800 times 10 to power minus 6 multiplied by 10, it becomes 800 times 10 to power negative 5. And then you divide every side by the whole of this, and our rho finally becomes 812. 812.5. Do not leave out the units. So this one is kg per cubic meter. So that becomes our final answer. So the first mark was either for the formula or this first substitution. Then the second mark was for the answer with the correct units. Then we can move to the next question. Figure 5 shows two springs C and D of the same length and equal number of turns made from the same wire. State with the reason which of the two springs can support a heavier load before attaining the elastic limit. So that is our next question. Which spring do you think it is going to support a heavier load without attaining the elastic limit? A simple case, which one is stronger?
D.
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 D is not strong. It is C. Remember, when the spring when it is going to have a smaller cross-sectional diameter, then it implies that it is going to have a larger elastic limit. So in this case, the answer is C. Then the reason, it has a longer or a larger spring constant or greater spring constant. So the answer is because it has a greater spring constant. We move to the next, sorry, because of those. We move to question number 13. Two boxes E and F of masses 2 kg and 4.0 kg respectively are dragged along a frictionless surface using identical forces. State with a reason which box moves with a higher velocity. So which box do you think is going to move with a higher velocity? Is it the one of 2 kg or the one of 2 kg? Louis Minor. Louis Minor, which one do you think is going to move with a higher velocity? Louis? Abdinajib?
The one with 2 kgs.
The one with?
The one with 2.0 kg.
The one of 2.0 kg. So you have 1 mark. Give us the reason.
Yeah, it accelerates faster than the one with 4.0 kg.
That is it. Because it accelerates faster than the 4 kg. So the answer is A, because it has higher acceleration. Let me just clarify this so that all of us will move together. Suppose you are to deal with this question and we apply Newton's second law of motion. F is equal to mass times acceleration, ma. Note that we are discussing about identical force, equal amount of force. For example, we can decide to make the force to be 20. If I make the force to be 20 and I pick this one of 2 kg, then it will be 2 multiplied by our A. So in this case, it means that our A becomes 10. But suppose now, remember we are still dealing with a force of 20 because it is equal identical force. We now substitute with 4 kg mass. So 20 becomes now 4. So in this case, we shall have 4 multiplied by A. So in this case, it means that our A becomes 5. So in that case, the acceleration of this 4 kg mass becomes 5. So that is what we are talking about, a smaller mass having a higher acceleration. We move on to the next question. Now we are in section B. A student is provided with 5 20-gram masses, a meter rule, a spring with a pointer, a stand, a boss, and a clamp. In the space provided, sketch a labeled diagram of the setup that may be used in order to verify Hooke's law using this apparatus. So in this one, you are supposed to sketch a full diagram on how to apply the Hooke's law. So in this one, in Hooke's law, we should have a stand that is going to support it. So let's say this is going to be our stand. And of course, labeling was a must. So you must show that you are looking at that this is a stand. So then, sorry for the mistake. Then from there, we are supposed to show the spring. So this is going to be our spring. And the spring, let it have a pointer. Show that it is supporting a mass. We must label this mass. So here we have our mass. Then a meter rule that will be showing the extension was a mass in this one. So where labeled diagram, you are given the mass. So this one you have to show that you're dealing with a rule. So, sorry, a rule in this case. So that is the diagram that was required of us. Then we can move to Roman 2. State 2 measurements that should be recorded in order to plot a suitable graph so as to verify Hooke's law. So which are the 2 measurements that we need? So the 2 measurements that we need, which are they? Mugambi, Mungeri. The 2 measurements give us one. Mugambi.
Force.
We have the force. Which force in this case? Remember, yes, it is a measurement. How do you obtain the force?
The weight.
That is it. So talk about the weight. Talk about the weight. Because the force here, you're talking about the force alone, it is not possible. You are not explaining where you are getting this force from. Then we get someone else, Ochieng Chienjo. Which are the measurements? Ochieng?
The extension of the spring.
That is it, the extension of the spring. So we can move to the next. Describe how the measurements made in Roman 2 can be used to determine the spring constant. Describe how the measurements in Roman 2 can be used to determine the spring constant. So one way is sketching a graph of force against extension and showing that it is a straight line. Then here you show that the slope is going to represent the spring constant. So when you are going to show that the slope is going to be the spring constant, then you are correct. So that is one way which you are marking that question. Then the other way is showing the formula, showing the graph, how it is going to be obtained, and then stating that the constant here is equals to the change of force over the change in extension. So that is how we can obtain it. Then we move to the next question. A helical spring stretches by 0.6 centimeters when supporting a weight of 40 grams. Determine the extension when the same spring supports a weight of 65 grams. So which formula are we going to use in this case? Nuru Fadeli, give us the formula for this one. Nuru? Nuru? Nuru, Nigel, Anuro, which formula are we going to apply? Nigel? Waturu Wainaina, which formula? Waturu Wainaina, which formula are you going to apply? Question B. Okay, students, work out this question and then you give me the answer. Work out the question.
Extension is 0.975 centimeters.
0.975. That is it, 0.975 centimeters. So somebody has given us the formula F is equals to KE. But for this formula to be marked, K has to be small, E has to be small. Note that, though we know that technicalities operating at the moment it can affect the nature of the formulas that we need in physics. So we can see that the weight is 40 grams. So it means that the weight here we shall have 0.4. So 0.4 is equals to, we want first of all to get the K. So our K times E, extension, we can see it is 0.6. So we are multiplying here by 0.6. So working on this, then our K, we get 0.4 divided by 0.6, which is going to give us 2/3 or 0.667. Let me just write it as 2/3. Again, applying the same formula of F is equals to KE. F being equals to KE, and I've talked about small e. Then our F, 65 grams, is the same as 0.65. So 0.65 is equals to K. Remember, we have already obtained our K as 2/3. So 2/3, we multiply with our E. So working out, multiply every side by the reciprocal of 2/3. Therefore, 0.65 times 3 divided by 2, we are going to get an answer of 0.975. 0.975 centimeters. So that is going to be our final answer. We now move to the next question. Question 15A. Figure 6 shows a bottle top opener being used to open a bottle. Indicate on the diagram the direction of the load and the effort. The direction of the load and the effort. So sketch it. Alan Moku has given us the effort. Unfortunately, there are some errors which I'm going to correct. Someone else is trying to show us. Okay. Can I delete everything that you have written so that I can give you the final answer? Delete everything, delete everything. Delete everything, please. More to delete, more to delete. Thank you. So remember force, load and effort, they are forces. You have to use a straight line. So in exams, you must use a ruler in this one. The other condition that you are looking at is that the effort and the load, they must touch. the opener itself. For example, this is the side of the effort. You show using an arrow and you label. Labeling of the forces is a must. This force, it is acting in opposite direction downwards. Let it touch this edge where we have the opener and the bottle top, and then you just label it as the load. So that is how we were supposed to work on it. Then we move on to the next question. State two ways in which an inclined plane can be made to reduce the effort applied, the applied effort when pulling a load along the plane. So two ways in which we can reduce the applied efforts. So two ways. William Otua. William Otua, can you hear me? William Otua. Mwadime, I want you to give us one way. Mwadime, can you hear me?
Yes.
Mwadime?
Yes, I can hear you.
Okay, one way of reducing the effort applied. One way.
Increasing effort
Okay,
distance.
Vincent Kyoko. No, the effort distance. Reducing the effort distance, no.
Increasing
the
effort.
amount of effort is pardon?
Increasing effort distance.
Increasing what?
Effort distance.
No, the variation of the distance will not change the amount of effort applied.
Can you say
making the slope less slopey?
Sure.
Making what?
The slope less slopey.
Reducing the angle.
Yeah.
Reducing the angle of inclination.
Yeah, the angle of inclination is reduced.
What about polishing the surface?
Increasing the load distance.
So,
Using yes, exactly. That one.
Okay, we have all the answers.
Using
I can see you have said making the incline to have a smaller angle. So that one is reducing the angle of inclination. That is one mark. The second mark, there is somebody who has said polishing the surface. Polishing the surface, the main aim is to reduce the frictional force. We were accepting several answers concerning the polishing of the surface. Some were using lubricating the surface. Others were saying using smoother surface, which is still correct. Others were saying by use of rollers and bearings. It was still correct because that it is essence of reducing the frictional force. Then we can move to the next question. A block and tackle system has 3 pulleys in the upper fixed block and 2 pulleys in the lower movable block. Draw a diagram to show how the angle can be set up in order to lift a load and indicate the position of the load and the effort. So you can sketch that one before I give you my final answer. Sketch it. Are you through?
Yes.
So you are through?
Yes.
Okay. Let me now give you the diagram. I had to give you time so that at least you can have your own creativity being applied in getting the right diagram. So in this case, we need to have a point of support. We are told that the upper block has 3 pulleys. So we need to have 3 on the upper block. So those are my 3 pulleys on my upper block. And then we have 2 pulleys on the lower block. So the lower block, let it start from here. And it has 2 pulleys. So we now sketch the block. For my case, let me just use a block as just a single line. It is going to serve the purpose. Then our effort applied at that point. Sorry. So this string runs over to the lower block, runs round to the top second block, goes round, then downwards to this one, and then it rises upwards to the last wheel, and then it gets attached somewhere here. So this question is supposed to award 3 marks. And if you look at my diagram, it is incomplete simply because we don't have the load. I normally tell the students that if you want your pulley system to be marked, point of support must be there. Then workable pulley system, effort, and the load being labeled. So don't forget that. Then we can move to the next question. State the velocity ratio of the setup. Velocity ratio of the setup. So we want to have someone who is going to answer for us. Owen Boothia, what is the velocity ratio?
5.
5. Simply the number of strings supporting the load. 1, 2, 3, 4, 5. Then we can move to the next question. In such a block and tackle system, an effort of 200 newtons is required to lift a load of 600 newtons. Determine the efficiency. So do the working, determine the efficiency.
%. 80%.
Pardon?
80%.
80%.
60%.
Yes.
Yes, yes.
You're getting 80%?
Yes.
Okay. Let's work on it. Have effort the load.
60.
60%.
50%.
Others are getting 80. Let me then work on it so that we can see the answer that we are going to have.
60%.
The answer, first of all, mechanical advantage, we know is equals to load over effort. So the load that I'm having in this case is 600. Effort that we are having, here it is, of 200. So once you work it out, we get 3. Then the formula for efficiency is equals to mechanical advantage over velocity ratio times 100%. This formula, for it to be awarded, this percentage symbol has to be there. It is a must. Then from there, our effort becomes mechanical advantage, we got 3. Velocity ratio we had in Roman 2 as 5. Multiply by 100%. So this is 300 over 5, that is going to give us 60%. So the answer to this one is going to be 60%. Then we move on to the next question. State the meaning of heat capacity. State the meaning of the term heat capacity. Collins Muthe? Collins Muthe, can you hear me? Collins Muthe? Collins Muthe? Jason Mubamia? Jason? Jason? Jason?
Yes.
Heat
capacity. Yes.
Okay, what is heat capacity?
Heat capacity is the amount of heat supplied to a given mass of material to produce a unit change in its temperature.
Something is incomplete. Something is incomplete. You have an idea, but not complete.
The quantity of heat required to raise the temperature of a liquid and
Quantity of heat energy required to raise the temperature of a certain mass through 1 Kelvin. 1 Kelvin.
Through
1 Kelvin.
1 Kelvin, that is it. It is the quantity of heat energy required to raise the temperature of a substance by 1 Kelvin. Quantity of heat energy required to raise the temperature of a substance by 1 Kelvin. Then we move to part B. State how pressure affects the melting point of a substance. State how pressure affects the melting point of a substance. Ryan Cheriot. Ryan, can you hear me? Ryan. 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 Vincent Mwiti, can you hear me? Vincent. Okay, William Otua is raising his hand.
Increase in pressure lowers the melting point of a substance, whereas a decrease in pressure raises the melting point of a substance.
Pardon? Repeat again.
An increase in pressure.
William.
Yes, sir. An increase in pressure lowers the melting point of a substance, whereas a decrease in pressure raises the melting point of a substance.
That is it. So increase in pressure, we had two options of the answer. William has given us the two. The first one, increase in pressure lowers the melting point, or decrease in pressure increases or raises the melting point. So those are the two options that were required in that question. We move to the next. Figure 7 shows a setup of apparatus that may be used to measure the specific latent heat of vaporization of steam. Describe how the mass of condensed steam is determined. How we determine the mass of the condensed steam. So how do we determine? Remember this. Let me just go back to the question itself. We are determining the latent heat of vaporization of steam. You have the electrical connectivity that is going to allow, this is not capacitor, it is the source of power, which is going to be the cell. So the heater here is going to get heated through electrical energy being converted into heat energy. Now, once this water is going to start getting heated, steam is going now to be produced. And the steam at 100 degrees Celsius is now going to pass through this condenser, and it is going to be condensed, and the condensed steam is now going to fall into this beaker. So the question is asking us, how are we able to determine the mass of the condensed steam? This mass, the first thing, you have to show some variables. You can use any unknowns, they are acceptable. First of all, you can talk about the mass of the beaker. So mass of beaker being the first thing. Mass of beaker. So suppose we see that the mass of beaker beaker when it is empty is X. Then this one already you are given our first mark for any variable of your choice. Then the second part is mass of beaker plus that condensed steam. So sorry, because of my handwriting at the moment. So mass of beaker plus the mass of the condensed steam. So whatever you get, suppose I just label it as Y. This one I'm awarded the second mark. Remember, first mark is here. But remember the question, we are expected to show the mass of the condensed steam. Therefore, the mass of steam, so here we have the mass of steam, being equal to this Y minus X. So in this case, you have to show Y minus X. And whatever you get, it is awarded the third mark. So that is how we were marking that question. We move on to the next question. Other than mass and time, state two other measurements that should be taken during this experiment. So two other measurements that should be taken. Ken Kahindu, can you hear me? Ken Kahindu? Ken Kahindu? We have Timothy Omonda. Timothy?
Yes, sir.
So give me other two measurements that should be taken in.
Pardon, sir, I cannot hear you.
Timothy, I'm asking.
Mass and time.
Yes. You're saying other than mass and time, state two other measurements that should be taken during the experiment. Yes, Timothy?
The temperature.
The temperature, no. If you look at the diagram itself, there is no part where we have the thermometer. So temperature cannot be taken in this one. So let's have someone else is going to attempt. Owen Budia.
Voltage.
Voltage. Correct. The other one is current.
Time.
The three are the measurements that should be taken. Then you move to Roman 3.
Time. No time.
We have said time.
Other than mass and time, so time.
Other than time.
Pardon?
In the question.
Oh, other than mass and time. So it is only potential difference and current. Because already we have mass and time. Then you can move to Roman 3. Show how the measurements in C Roman 2 can be used to determine latent heat of vaporization of water. Therefore, remember we are using electrical energy. And the electrical energy in this case is V, potential difference, times the current times time. This electrical energy is being used to vaporize the water, the liquid. Therefore, is equals to quantity of heat of vaporization. Therefore, it is mLV. Working on this, you get 1 mark. So this part is not a must. Let me just erase it so that we deal with the first, the second, and this part now. So this way you now get the first mark. Then the second mark, remember the question, to determine the specific latent heat of vaporization, which is this one, you make LV the subject. So making our LV the subject, it is therefore going to be VIT over M. So that becomes our final answer. We now move to the next question. State the precaution. State the precaution that should be taken so that the mass of the condensed steam measured corresponds to the actual mass of steam collected during the time recorded in the experiment. Remember that this is a topic whereby we do some assumptions because of the heat loss to the environment. So we have to take a lot of precautions so that we minimize the heat loss to the environment. So one of the precautions, you need to start timing immediately the circuit has been set off, or immediately the boiling has started, and you stop the timing immediately you have collected a particular amount of steam, condensed steam. So nimesema kwamba you start the timing immediately the boiling starts, and you stop the timing immediately you have collected a particular amount of condensed steam. So that is the major precaution that you're supposed to have. Then Roman 5. So state why it is not necessary to measure the temperature in this setup. Somebody has talked about the thermometer. Regan Okov, can you hear me? Regan? Regan Okov? Onyancha Craig? Onyancha?
Yes, sir.
Onyancha Craig?
Yes, sir.
Why is it not necessary to measure temperature?
From the formula.
Onyancha, why is it
Yes,
not
sir.
necessary to measure the temperature? I can't hear you.
I think.
I can't hear you. Macharia David?
Yes, sir.
Why is it not necessary to measure temperature in this setup?
Steam boils at 100 degrees Celsius.
So in that case, it means that steam is being collected at a constant temperature. Steam is being collected at a constant temperature. It's being collected at a constant temperature. Or somebody saying that there is no change in temperature during the experiment, it is allowed. There is no change of temperature during the experiment, it is allowed.
Yeah, question.
Yes?
Can you also say in the experiments there is only change of state? From gas to...
Unless you state that during the change of state, there is no change in temperature. That one is much suitable. During the change of state, there is no change of temperature. So we can move to question number 17. What is meant by Brownian motion? What is meant by Brownian motion? Maxwell Amani, can you hear me? Maxwell Amani? Maxwell Amani? Maxwell? Leon Otuoma? Leon Otuoma? Leon Wamba, can you hear me? Leon Wamba? Leon Wamba, can you hear me?
Yes.
Some
Yes.
students have. Okay, Leon, what is meant by Brownian motion?
This is where particles of the matter are involved in constant random motion.
It is where particles. Repeat again.
Yes.
Repeat your answer again. So, Leon Wamba.
Yes. Yes.
Leon.
Yes, sir.
Repeat your answer.
This is where particles of a specific state of matter are involved in a constant random motion.
That is it. Or in short, it is the random movement of particles of matter. It is the random movement of the particles of matter. Other answers that we are accepting is zigzag movement or zigzag motion. Others we are talking about haphazard motion of the particles in a matter. All those answers are correct. Then we move to question B. Figure 8 shows a graph of velocity against time for a small steel ball falling in a viscous liquid. So we can be able to see the graph of velocity against time, and we can see point between O and A and then B. Then the question that follows is asking, describe the motion of the steel ball represented by the part OA. The part OA. So part OA, what does it represent? So
Acceleration.
we have Michael Gumbi. Michael Gumbi? Michael Gumbi, can
Yes.
you hear me? Michael Gumbi. Part OA, what does it represent?
Acceleration.
Pardon? Michael Gumbi, repeat your answer.
It represents acceleration.
What kind of acceleration? It is an acceleration, but is it constant acceleration, increasing acceleration, or decreasing? Paul Wafula. Wafula Paul, can you hear me? Paul Wafula. Peter Njogu. Okay, let me give you the answer. OA represents a decreasing acceleration. This is a decreasing acceleration. Don't just talk about acceleration, because acceleration, it can increase, decrease, or constant. If it was constant, it was supposed to be a straight line for a velocity time graph. If it was increasing, it could have moved in this manner. But now, because it is decreasing, then that is how it is going now to be formed. So this is decreasing acceleration. Explain why the velocity between A and B is constant. Why do we have a constant velocity? Why do you have a constant velocity? Pardon? Why do you have constant velocity? Regan Okov. Regan, can you hear me? Regan, Kent Kamunya. Kent Kamunya, can you hear me? Kevin Mudama. Kevin Mudama.
This is because between A and B, it has reached terminal velocity. So the velocity is constant.
I think you have an idea. Note that the question is awarded 3 marks. Maria Collins.
This is because this is because the mass has it's because the ball has reached terminal velocity where the weight is equals to the both viscosity and average force.
That is it. So first mark is to state that the body has reached the terminal velocity. Then the second mark is to state that the weight of the body is balancing with the upthrust. Ama unaonyesha kwamba W is equals to upthrust plus viscous force. That is where we get the second mark. Then the third mark, you have to show that the net force acting on the body is 0. Net force acting on the body is 0. I repeat the answers to that. We have said that the first mark, the body has reached terminal velocity. Second mark, weight is equals to upthrust plus viscous force. That mark, the net force is 0. The net force acting on the body is 0. We now move to question C. Question C, a student throws a tennis ball vertically upwards from the ground and it lands back after 8 seconds. Acceleration due to gravity G is equals to 10. Determine the maximum height reached by the ball. Determine the maximum height reached by the ball. Kindly do the working so that you can get the final answer. Once you are through, you tell me the answer. What is going to be the answer? I'm waiting for the answer.
Is it 40?
You're getting 40 meters.
Yeah.
Yes.
So are we getting 40 meters?
Yes.
Okay. Let's work on the question and see how we can manage it. In this case, we are told a student throws a tennis ball vertically upwards. If you are throwing upwards, then automatically acceleration now becomes -10. A is -10 because it is moving in opposite direction, the gravitational pull. And if it is going to land after 8 seconds, that means that time taken to reach the maximum height is 4. You simply divide that 8 by 2 because 8 seconds is time for rising upwards and then dropping, and the time is going to be the same for rising and dropping. Therefore, you divide by 2. So this body, for to reach maximum height, so in that case, because now the final velocity is going to be 0. First of all, why don't we get the initial velocity of throwing this ball? Actually, this working, we can work it here. So we know our formula B is equals to U plus AT. So that is our first formula. 0 is equals to our U, then plus A, we note it is -10. So -10 times T, our T is 4. So we are multiplying this one by 4. Once we multiply by 4, this is -40. Bring it to the other side, it becomes +40. So our U in this one, it is going to be 40 meters per second. 40 meters per second. Now, because already you have our U, and the question is asking us to get S, this one you have our 40, and you want our S. So we apply the formula that is going to have this square. We are having a lot of background noise. So this squared is equals to u squared plus 2as. B squared is 0, is equals to u squared that we got as 40. So this is 40 squared plus 2. Our A is negative 10 s. Then you multiply by s. Therefore, this becomes negative 20s. Negative 20s, take it to the other side, it becomes positive 20s is equals to 40 squared is 1,600. So what is going to be our S? 1600 divided by 20, we get
80. 80 meters.
80.
We have some students who had gotten 80 meters.
Yes.
Yes, Mwalimu.
Yes. Yes, Mwalimu.
Yes.
Yes,
So
Mwalimu. Yes.
it becomes the answer. We can now move to the next. The figure shows a graph of pressure against temperature for a fixed mass of a gas at a constant volume. We can be able to see the graph of pressure against the temperature in Kelvin. From the graph, determine the value of N given that, and C, given that P is equals to NT plus C, where N and C are constants. Look at the question itself. Is it obeying the rule of Y is equals mx plus C? The graph is a straight line. Is it obeying the rule of Y, the equation? Is it obeying the equation of Y is equals to mx plus C?
No. Yes.
Yes. So
Yes.
in that case, our p-axis is the y-axis indeed. Our t-axis is the x-axis. Therefore, N, how do we get N? How do we get N?
Slope.
How do we get N?
Find the gradient.
The gradient.
Please, there are some who are muting and yet they have a background that is affecting the whole class. Please stop doing that. So, can you first of all get the slope of the graph? For us to be able to obtain the slope, we can just identify some points and then we work. I want us to work with 4 against 2, work with against 2, and we work with 8 against 5. So work with those values. Let us get the slope. Because you have seen that N is the slope. So let's get the slope.
$1.333.
1.333.
Yeah.
Yes.
Yes.
This one becomes 8 minus 4. We have 8 minus 4. But please note that it is 8 minus 4. Here it is times 10 to the power 2. So you must take care of it, times 10 to the power 2. Hoping those who are getting with this one, then it is 5. Please, if you have a background noise, let it not be displayed in the class. Then we divide by 5 minus 2. And this is going to give us 4 times 10 to the power 2, which is the 400 over 3.
Imepanguzwa asubuhi gani?
The answer is 133.33. So that is going to be our final answer. Then we can move to the other one. Any question? Any question? Or it is just background noise?
Chair, I have a question.
How do you get the value?
Chair, you see. But Chair, when you see the scale ya inaitwaje? Pressure.
Okay. How do we get the value of C? How do we get the value of C?
The
That
y
should be our next.
the y-intercept.
Y-intercept. So
The
in
y-intercept.
example, y-intercept is correct. Take your ruler, extrapolate or extend this line where it is going to land. Whatever you get becomes the answer. So like in this case, it is 1.0, 1.0. But remember, the values of y-intercept here are times 10 to the power 2. So it is 1.0 times 10 to the power 2 times 10 to the power 2 over 2 Newton per meter squared. Newton per meter squared. So that becomes our answer. We move on to the next. Why is it not, explain why it is not possible to obtain zero pressure of a gas in real life situation? Why is it not possible? Why is it not possible? We are having a lot of back. Why is it not possible? Why is it not possible? Francis Kyoko?
Sure.
Yes.
I think because there's at no point will the volume of any matter become zero.
Yeah. There is no way the volume of the matter of the gas becomes zero. That is one. So in this case, when you are going to force the pressure, gas, maintain zero pressure, the gas is going to require. I'll have to unmute some of the students because here they are affecting our learning. So we are saying that the gas is going to liquefy at zero pressure. So the gas is going to liquefy. Then we can move to part C. A fixed mass of gas occupies 1.5 times 10 to the power minus 3 cubic meter at a pressure of 760 millimeters of mercury and temperature of 273. Determine the volume of the gas, the volume the gas will occupy at a temperature of 290 Kelvin and a pressure of 720 millimeters of mercury. Quickly do the calculations and you get the final answer. Work out on that question. Whoever is writing on the page, kindly delete whatever you're writing. I'm waiting for your answers. Yes, what answer are you getting?
1.682 times 10 to the power negative 3.
Times 10 to the power negative
3.
3. So are you getting that answer? Do you have several students who are getting the same answer?
Yes.
1.682 times 10 to the power minus 3.
Yes.
Yes.
This one, we are dealing with P1 over T1 is equals to P2 T2 T2. Whoever is writing, can you stop that, please? There are some students we shall not entertain. We just remove them from this forum because I think they are not becoming a nuisance. So once you substitute this one, so the moment you substitute this, the final answer comes from 1.682 times 10 to the power negative 3, 10 to the power minus 3 cubic meter. So this becomes, then you go to question D. State 3 assumptions made in one assumption.
The gases are ideal.
The gases are ideal, not complete. It's an ideal gas. Yes, Alfredo Panda. Alfredo Panda.
Easy more.
Alfredo Panda. Alfred. Abdinajib.
Yeah, the volume of the gases at zero pressure. Zero.
The volume
of the gases.
I can't hear you. I can't hear you.
Yeah, the volume of the gases at zero pressure is 0.
That one we may not apply it in this case. So the assumptions, one of it, the time of collision between the molecules of the gas is negligible. The time of collision between the molecules of the gas is negligible. The time of collision between the molecules of the gas is negligible. That is one. The second one, we talk about the masses. The mass of the molecules of the gas is negligible. The mass of the molecules of the gas is negligible. The mass of the molecules of the gas is negligible. Then we move to the third assumption. The collision between the molecules is elastic. The collision between the molecules of the gas is elastic. Between the molecules of the gas is elastic.
Question, excuse me, sir.
When
you say collision between molecules elastic, what do you mean? What is the literal meaning of that? Yeah.
That those gases, remember, we usually talk about random movement of the gas molecules when they are colliding. And for them to collide, they are supposed to collide and leave each other so that the randomness can proceed. So for it to be facilitated, then it means that they must have that elastic nature. They collide and separate, not colliding and sticking to each other.
Oh, thank you.
That is the meaning. So with that, we are through with paper 1. During the next lesson, we shall go through paper 2. And God willing, we be able to cover all the KCSE papers that we've covered so that at least we prepare you for the final exam. Otherwise, thank you very much. And something I wanted to state is that during next lesson, we shall only accept questions from students who are going to show us all their true names. For example, there is somebody who is having a very unique name. I cannot be able to read it. So in that case, we will allow those students to answer. Therefore, let us have a good class participation. Thank you very much. God bless you.